Right now, somewhere above your head, a bird is probably sitting on a wire. You barely notice it. It's just a bird. But that bird is a dinosaur. Not a metaphor, not a nickname. A living, breathing descendant of the same family tree that once produced 40-ton predators and animals taller than a 4-story building. And the reason you're not sharing your street with something the size of a school bus has nothing to do with evolution slowly phasing them out. It happened in a single afternoon. But before you get to that afternoon, you need to understand what was lost. Because for 165 million years, dinosaurs weren't just surviving on this planet. They were running it. Picture Earth 70 million years ago. The continents are drifting into shapes you'd almost recognize. The air is thick, warm, humid. Ferns the size of houses line the riverbanks. And underneath that canopy, life moves differently than it does today. A Tyrannosaurus rex doesn't hunt like a lion. It doesn't need to. Its bite alone generates more force than any land predator in Earth's history, before or since. Paleontologist Steve Brusata has spent decades studying these animals up close, and his research suggests a T-Rex could crush bone the way you'd crush a cracker. Not tear flesh, crush skeletons whole. Now picture a Triceratops on the other end of that bite. 3 horns, a neck shield built like armor plating. It isn't running from a fight. It's built for one. Further off, a herd of duck-billed hadrosaurs grazes on cycads and conifers, migrating in massive groups the way bison once crossed the American plains. Some scientists believe they even called to each other using hollow crests on their skulls, honking low-frequency sounds across the tree line. Above them, pterosaurs with wingspans wider than a small airplane glide on thermal currents, scanning the water for fish. Along the coastlines, the oceans have their own rulers. Mosasaurs, giant marine reptiles stretching over 50 feet, patrol the shallow seas like torpedoes with teeth. They aren't dinosaurs exactly, but they belong to the same age, the same fragile balance of power that seemed permanent from the inside. Smaller dinosaurs move through the undergrowth too, easy to overlook if you only picture giants. Feathered raptors, some no bigger than a turkey, hunt in the shadows of ferns, quick, clever, endothermic enough to stay active, even as temperatures shift through the day. Fossil evidence suggests many of them slept curled up, tucking their heads under their arms almost exactly the way a bird does on a cold night. This wasn't a lost world. This was a functioning one. Predators and prey locked into a balance that had already lasted longer than mammals had even existed as a serious presence on land. Generation after generation, nothing about this arrangement seemed temporary. Fossils show the same predator-prey relationships repeating for millions of years without major disruption. Triceratops fought Tyrannosaurus the same way their ancestors had fought each other's ancestors, decade after decade, era after era, with no sign that any of it was building toward an ending. Nothing in their biology could have prepared them for what was coming. There was no warning system for this, no slow buildup they could sense and adapt to. Nature had never asked this ecosystem to survive anything like it before. So here's the question worth sitting with for a second. If this ecosystem was so dominant, so specialized, so successful for 165 million years, what could possibly end it? Not a slow decline, not a gradual climate shift they simply failed to adapt to. Something faster, something almost impossible to imagine at that scale. In 1980, a father and son research team, physicist Luis Alvarez and his geologist son Walter Alvarez, found something strange buried in rock layers in Italy. A thin band of clay, barely visible, sitting exactly at the boundary where dinosaur fossils stop appearing. That clay was packed with iridium, an element that's rare on Earth's surface but common in asteroids. Their conclusion sounded almost too dramatic to be real. Something from space had hit the planet, and it had hit it hard enough to leave a fingerprint in rock on the other side of the world. For years, other scientists pushed back. Extraordinary claims need extraordinary evidence. Where was the crater? Then, in the early 1990s, researchers located it. Buried under the Yucatan Peninsula in Mexico, hidden beneath jungle and limestone for 66 million years. A crater roughly 90 miles wide named Chicxulub after the small town nearby. The object that made it was likely 6 miles across. To put that in perspective, that's wider than most cities you've driven through. It struck at somewhere around 45,000 miles per hour. Try to hold that number in your head for a second. Now try to imagine what happens in the seconds after impact. The asteroid didn't just crash into the ground, it vaporized instantly, along with the rock beneath it, releasing energy equivalent to billions of atomic bombs detonating at once. Within minutes, a shockwave flattened everything for hundreds of miles. Trees, animals, entire ecosystems gone in an instant, the way a hand sweeps crumbs off a table. But the animals closest to the impact were, in a strange way, the lucky ones. Their deaths were fast. What came next was slower and far more brutal. The impact threw molten rock and debris high into the atmosphere, so high that some of it left the atmosphere entirely, only to fall back down across the globe as it re-entered. That falling debris superheated the air on the way in. Scientists studying this event believe the sky itself briefly turned into an oven. Not everywhere at once, but in waves, as debris rained back down for hours. Forests thousands of miles from Mexico may have ignited on their own, simply from the radiant heat pouring down from above. In 2019, a discovery in North Dakota gave researchers something they never expected. Paleontologist Robert De Palma uncovered a site now known as Tanis, which appears to preserve the very day of the impact itself. Fish fossils with tiny glass beads, called tektites, lodged in their gills. Beads that only form when molten rock is thrown into the sky and cools mid-air, then rains back down. Those fish didn't die from fire. They died from a wave, possibly triggered by seismic shaking from the impact itself, arriving in a river system thousands of miles from the crater within the same hour the asteroid struck. That's how far the damage reached, in less time than it takes to watch a movie. But the fire and the waves weren't even the worst part, because after the burning stopped, the sky didn't clear. Soot, sulfur, and pulverized rock stayed suspended in the atmosphere, blocking sunlight across the entire planet. Some researchers estimate the skies stayed dark enough, for long enough, to shut down photosynthesis almost completely. Think about what that actually means. Plants stopped growing. Not for a day. Possibly for months, maybe longer. And if plants stop growing, what happens to everything that eats plants? And what happens to everything that eats the things that eat plants? The food chain didn't collapse slowly. It collapsed from the bottom up, all at once, like pulling the foundation out from under a building and watching every floor above it fall in sequence. Temperatures may have dropped sharply worldwide, even in places that were tropical the week before. Animals built for warmth, animals with no fur, no insulation, nowhere to hide from a sudden winter they'd never evolved for, had almost no way to cope. Paleobotanist Peter Wilf, who has studied fossilized leaves from this exact period, found something telling in the plant record. Right at the boundary, diverse, healthy forests vanish almost completely, replaced for a stretch of time by simple fern species. Ferns are often the first plants to recolonize scorched, damaged land. Their sudden dominance in the fossil record, what scientists now call the fern spike, reads like a scar left behind by something catastrophic. The oceans weren't spared either. Falling debris and acid rain changed the chemistry of the water itself, and with sunlight blocked, the tiny plankton at the base of the marine food web began dying off in massive numbers. Remove the bottom of that chain, and everything above it, shellfish, fish, the giant mosasaurs patrolling the shallows, loses its food source in the same collapse. How long did this darkness last? Estimates vary, but many researchers now believe it stretched on for a year or more. Not a bad week, not a rough season, an extended planet-wide famine with no clear end in sight for anything living through it. Here's the part that tends to surprise people the most. Size, the very thing that made dinosaurs so dominant for 165 million years, became a death sentence. A massive animal needs massive amounts of food every single day just to survive. In a world where food had nearly vanished, there was no way to outlast the famine. Smaller animals had an advantage nobody was expecting. Creatures that could burrow underground, that needed very little food, that could survive on seeds, insects, or scraps, had a chance the giants simply didn't. This is where the story takes its strangest turn. Not every dinosaur died. One branch, small, feathered, lightweight, had already been evolving in a very different direction for millions of years before the impact. Their bodies needed less food. Their size worked in their favor instead of against them. You call their descendants birds. Every sparrow on a fence, every pigeon in a parking lot, every crow watching you from a wire carries the direct lineage of the dinosaurs. They are not a comparison. They are not distant cousins. They are dinosaurs, just smaller and just quieter about it. So when you look up and see a bird today, you're not looking at something new. You're looking at the only branch of an entire dynasty that found a way through the worst single day in the history of life on Earth. And maybe that's the part worth sitting with, more than the fire, more than the crater, more than the number 66 million. For 165 million years, being the biggest, the strongest, the most dominant thing in the room was the winning strategy. Until, in one afternoon, it wasn't. What survived wasn't the most powerful. It was the most adaptable. So the next time a bird lands near you and you barely give it a second glance, remember what it actually is. A 5-foot-tall predator that once ruled an entire planet, quietly rewritten by 66 million years of survival, small enough now to sit on a wire above your head and not think twice about you at all.